negative. So positive and negative, add I to the second one. So copper chloride. So if I had potassium and bromine, and I had to put potassium and bromine together, potassium is positive, bromine's negative, how would I say that? Yes.
Potassium bromide?
Yes, potassium bromide. If I had calcium and sulfur to put together, how would I say that? Calcium's positive, sulfur's negative, so how would I say it? Yes.
Calcium sulfide?
Calcium sulfide, not sulfuride, calcium sulfide. Okay, so if I were putting lithium and oxygen together, lithium's positive, oxygen's negative, how would I say that? Yep.
Lithium oxide.
Close. Yes, lithium oxide. So positive, then negative, add the I to the second word. Yes.
If you have like, if you have two numbers and they're both positive, like carbon and
We're not going to put two positives together. Okay? All right. Not in this type. Okay? All right. So we know positive goes with a negative, yet we've got a whole set up there that have no number attached to them. All those transition metals, there's no number attached to them, no oxidation number. So what do we do about that? Well, when an element has a variable oxidation number, you will usually see its proper name followed by a Roman numeral, and that is the oxidation number. Okay, so in this case, copper 1 has an oxidation number of +1. Copper 2 would have an oxidation number of 2+. This iron here, oxidation number 2+. Lead 4, oxidation number 4+. They are positive numbers. Yes. Go ahead.
Thank you.
Okay. Now, you need to put the Roman numeral because copper comes in copper 1, copper 2, copper 3, copper 4. So you absolutely need to write the Roman numeral when it comes to these variables. And now I will usually give you that number. If not, I usually will give you a formula where you can backwards work and figure it out. Okay? So, Roman numeral to show the oxidation number. You might sometimes see it written this way, with the actual oxidation number written there. So I might have the proper name and the Roman numeral, or I might have the chemical symbol and the actual oxidation number written superscript above it. Okay, so in this case, it is 2+. Alright, so now we've got to figure out what to do with these oxidation numbers when we're putting them together. Alright, so we now know the oxidation number. We now have a set of rules to follow. We said that we put the positive number first, and we put the negative number second, and we add I to the end. But that's if we're saying it. That's if we're saying the proper name. What if we're writing it as a chemical formula? This is what we have to do. Again, positive first, chemical symbol, negative chemical symbol second, and then we add no subscripts or subscripts as needed until our oxidation numbers equal 0. So let's see what that looks like. If I have hydrogen and oxygen, and I need to write the binary chemical formula for hydrogen oxide, okay, which one is positive?
oxygen.
Hydrogen has an oxidation number of 1+. So that one's going to go first. This one has an oxidation number of 2-. So that one's going second. First the positive, then the negative. Now, I need these numbers to equal 0 if I add them together. Do they equal 0 right now? No. So what I need to do is find the least common multiple of those. What's the least common multiple of 2 and 1?
1.
2, 0.
Not integer, not factors, multiple. What's the least common multiple of 1 and 2? 2. Okay, so I need to get these to equal 0 by using the least common multiple of 2. All right, this one's already there at 2. I need to multiply this by 2 to get to 2. So it's now 2+. Okay, so how many of those did it take to get 2+?
1,
2 of them. All right, so it took me 2 of those to get to 2 plus to balance out 2 minus. So I now have H2O. What's that?
Water.
Water. If I were going to say it in its long name, what is it? Hydrogen oxide, but some of these have typical names. For example, if I have Na and Cl, what's the oxidation number for Na?
1 plus.
1 plus, and what is it for chlorine?
1 minus.
1 minus. Okay, does that equal 0? Yes. So I only need 1 of each of those. Now, if I were saying that, I would say sodium chloride, but we know it as just regular old table salt. All right, so let's look. Going back to these that we did earlier. You put lithium and sulfur together. Now, what's the oxidation number for lithium? 1 plus. And what is it for sulfur?
2 minus.
2 minus. Does that equal 0?
No.
No. So how many lithiums do I need to balance out the sulfurs? 2. So I end up with Li2S. And how would I say that? Lithium sulfide. And when you put it together on your little board, did you have 2 lithiums and 1 sulfur?
Yes.
Yes, you did. Okay, you really didn't know how to put it in a formula or name it yet, but that's what you came up with to get 8 valence electrons. Secondly, you did magnesium and oxygen. What's the oxidation number for magnesium?
2 plus.
2 plus. What is it for oxygen?
2 minus.
2 minus. Does that equal 0? Yes. So, do I need just 1 of each?
Yep.
Yes. So, MgO, magnesium oxide. Now, here's where some of you need to be really careful about using lowercase letters and uppercase letters. Because on your quizzes before break, some of you were using capital. If I had COS, that looks to me like copper, carbon, oxygen, and sulfur. Whereas if I have COS, I've now got cobalt and sulfur. Okay, so those capital letters become very important with the lowercase letters. So please be sure you're using capitals and lowercase. All right, next one you had was calcium and chlorine. What's calcium's oxidation number?
3 plus.
2 plus. Chlorine?
-1.
-1. Does that balance? No. How many chlorines will I need to balance the calcium?
2.
2. CaCl2. Okay, and what's it called?
Calcium chloride.
Calcium chloride. Okay, and then you had sodium and iodine. What's sodium?
+1.
1 plus, and iodine?
-1.
1 minus. Is that balanced? Yes. So NaI, sodium iodide. Sodium iodide. All right. So if you think back, when you put them together on your little cardboard, that's exactly what you had. You had lithium that had 2, and you had chlorine that had 2 hooking together. Okay. So, and that's what should have happened. That should have matched these just by balancing the oxidation numbers. All right. So we know that we put positive first, negative second. We make sure that the oxidation numbers balance out at 0. If not, we use least common multiple to find out how many we need to balance it out at 0. If we have a variable oxidation state, then we need to use the Roman numeral to find out what the oxidation number is. And the proper name will contain a Roman numeral, or you will see a chemical symbol with the oxidation number written above it. We're going to stop there for right now because we don't have time to get fully into the next little bit. So we will pick up with what to do with variable oxidation numbers next time. Okay. Any questions about that thus far?